We're going to be looking a little more in depth at the selection or the decision control structure. You'll usually see this in code as an if or an if-then type of statement or structure. The decision to be made in code would be something like this. If this condition happens, or if this happens, or if this is true, then do this. And then sometimes it would also be if this happens, or if this is true, then do this, otherwise do this. This control structure makes programs much more useful and responsive, and they will accept and react to the outside data, making your system more interactive. The branching instructions tell the computer to run different instructions depending on the value of certain data. If the user is taking a quiz, for example, different code could run if they get the answer right versus if they get it wrong. A condition will be checked, and in the example of the quiz, the condition would be to check to see if the user got the answer right. If the condition is true, certain code will run. If the condition is false, another set of code is going to run. Or in some cases, nothing at all will run. It will go to the next set of code past the branching instructions. So, what do these conditions look like? Before we go a little further with the selection control structure, let's look at the conditions or the questions that we ask that decide what code will run. As humans in our everyday life, we might ask something like, do I have enough in my bank account to withdraw $100? We take a look at our bank account, our bank balance, and the answer would be either yes or no. For a computer, instead of yes and no, it uses something called a Boolean expression. It's the computer's way of asking a yes or no question. A Boolean has two values. It's either true or false. So the computer code might read something like if, and then inside parentheses, the condition, which is if account balance is greater than or equal to 100, then we can withdraw $100. Else, we have insufficient funds. So the portion in the parentheses is the condition that's being checked that will determine what code runs. If account balance is greater than or equal to 100, if that's true, then the withdraw 100 will run. If the account balance greater than or equal to 100 is false, then insufficient funds will print and that will run. You might remember relational operators from elementary school. The greater than sign, where the crocodile mouth eats the bigger number, or an ending angle bracket is what it's called. And then the less than sign, the opening angle bracket. So the following expressions might be familiar to you. It's the same relational operators that you use in programming. So for, and then the opening angle bracket 6 reads 4 is less than 6, and the Boolean value of that is true. 4 is less than 6. If we have 4 ending angle bracket, or 4 is greater than 6, the Boolean value of that is false. 4 equals sign 6 reads 4 is equal to 6, and the Boolean value of that is false. 4 is not equal to 6. Some languages use the double equal sign with two equal signs to mean equal, so it doesn't get confused with the assignment operator. All right, let's go on. 4 opening angle bracket equals sign 6 reads 4 is less than or equal to 6, and that Boolean value is true. And 4 is greater than, or 4 ending angle bracket equals sign 6 reads 4 is greater than or equal to 6, and the Boolean value of that is false. And we also have the not operator, so 4, and then you have an opening and an ending angle bracket 6, reads 4 is not equal to 6, and that is true. The Boolean value of that is true. Some languages use the exclamation to mean not. So instead of the opening and closing angle brackets, it would be a exclamation equal sign for not equal to, or an exclamation double equal sign for not equal to. The simplest selection structure is the if or the if-then statement, which will offer a set of instructions to follow. If the Boolean value expression is true, that will then run the code following it. We've seen this logic in our pseudocode that we've done in the past. The syntax usually used with programming languages is the if keyword followed by the condition or decision that will be checked, sometimes inside parentheses. And then the keyword then might be used, or more commonly an opening curly brace will start out the code that runs if the condition is true, ending with a closing curly brace to show when the code ends. That will run when it's true. So we have if, and then condition, then, and then code to run. So our bank example would look like this. If, opening paren, account balance greater than equal to 100, ending paren, then withdraw 100. Or another syntax might look like if, and then opening paren, account balance greater than equal to 100, closing paren, opening curly brace, withdraw 100, ending curly brace. So if you had a question your user was answering and you wanted to check if they were right or not, for like the quiz example, your code might look like this. If, opening paren, answer is equal to, the double equal sign, correct, ending paren, then print you're correct. Notice we're using variables in our condition for both of these. The bank example uses the value that's stored in the account balance variable. This variable could hold the value of $75, which would mean the condition would be false. The variable could hold the value of $150, which means the condition would be true. The question example is using two variables, answer and correct. If the user chooses, for example, answer A, then answer would store A as the data. Then if the correct variable also stored the data A, meaning A was the right answer, then that condition, answer equal to correct, would be true. With the if or if-then statement, you can see it used with different syntax depending on the programming language. Visual Basic would look like this. If, and then answer equal correct inside parens, then console.writeLine, you are right inside quotes and parens, and if. C++ would look like this. If, and then inside parens, answer, double equal sign, correct, curly brace, C out, you're right, inside quote marks, semicolon, ending curly brace. JavaScript would look like this. If, and then inside parens, answer, double equal sign, correct, opening curly brace, document.write, you are right, inside quotation marks and parens, semicolon, ending curly brace. Ending curly brace. Swift would look like if, answer, double equal sign, correct. Notice it's not in parens this time. Opening curly brace, print ln, and then you are right inside quotation marks and parens. Swift shouldn't have a semicolon. And closing curly brace. Don't worry about remembering all that syntax, especially the different ways to print to the screen. We haven't even got to that yet, but the if-then logic is what I want you to remember and see that it will be similar in all the different languages. Once you know these control structures, the syntax will be the only difference between the languages, allowing you to learn them all quickly once you understand just programming in general. Okay, another thing you'll want to understand about condition statements is that you can evaluate multiple Boolean expressions using the AND operator and the OR operator. So, our first example here, to vote in the United States, you have to be 18 and you have to be an American citizen. Both conditions have to be true in order for you to be able to vote. This might be how you'd see it in pseudocode. If age is greater than or equal to 18 and citizen is equal to yes, then you can vote. So both the conditions, age is greater than or equal to 18 is true, and citizen is equal to yes is true for the code below to run it all. So with the AND operator, both conditions have to be true for the code to run. Let's look at the OR condition, or OR operator. With the OR operator, only one condition has to be true for the code below to run. Let's say you're trying to get a scholarship to college. You either have to have a high GPA or you have to be a great athlete. Either one of these conditions would allow you to get a scholarship. Only one needs to be true for that to happen. This might look like what the pseudocode looks like. If GPA is greater than or equal to 3.8, or your athletic skill is equal to great, then you can have a scholarship. You would only need one or the other for you to get the scholarship. Let's look at some examples in code. In some languages, the AND is represented by a double ampersand, and the OR is represented by a double bar. So there we go, and double ampersand or double bar, not represented by an exclamation. So those are just three things you will need to recognize there. Okay, so JavaScript. Variable age, bar age equal 16, semicolon, bar citizen equal quotation marks around yes, semicolon. If age greater than or equal to 18 and citizen is equal to yes, then document.write, you can vote. Then for the scholarship example, var GPA equals 4.0, var athletic skill equals poor. So if GPA is greater than or equal to 3.8, double bar, athletic skills equal to great, document.write, you get a scholarship. Okay, C++. We have an int variable, int age equals to 16, semicolon. Character char, citizen equals yes. If age is greater than or equal to 18 and citizen is equal to yes, C out, you can vote. Double data type GPA variable 4.0, character athletic skill equals poor. If GPA is greater than or equal to 3.8, or with a double bar, athletic skills equal to great, C out, you get a scholarship. All right, so that's just a couple of syntax differences we can see there. Okay, so let's look at just this example here. We have the variable 3.9, but they are a poor athlete. But remember, with the OR, only one of the conditions have to be true for the code to run with the within the curly braces. So let's just change the variables around a little bit. If we had a variable value GPA of 3.2 and the athletic skill was great, then only one condition is true. Only one condition has to be true with the OR, and that's all you'll need to have those two combined conditions to be true overall. So if their GPA was low but they were a good athlete, they would still get a scholarship to show up on the screen. If the GPA is 3.2 and the athletic skill is poor, so we have a low GPA and a poor athletic skill, both are false, then the combined conditions will then be false, and you will not see anything on the screen. The voting example, let's go back actually. We're down here. If the, this was using and both conditions had to be true for the code to run. We see that they are a citizen, but they're not old enough. So only one condition is true, and the overall combined Boolean would be false. The code in the curly braces won't run. If the age changed to 22 and the citizen is no, then they can't vote again because both conditions have to be true. If the age is 22 and the citizen is no, then they can't vote again. But if the age is 22 and the citizen is yes, then both are true, and then that is the only time that you would see the text that you can vote. Okay, so far we've just been using an if-then statement where if a condition is true, a set of code will run. If the condition is false, then nothing happens. This is called a single alternative. What if we have two different alternatives? If a condition is true, run certain code. If it is false, then run a different set of code. It's either one or the other, never both. For these dual alternatives, we will use an if-else statement or an if-then-else statement. Let's look at our same example of JavaScript with a dual alternative. Here we have the variable age is equal to 16, variable citizen equal to yes. If the age is greater than or equal to 18, which it's not, and the citizen is equal to a yes, then that will not run. But it will jump down to the else, and it will run you cannot vote. You can also have multiple alternatives as well. For example, here is an example of Java using an if, else if, and an else statements. So it has an integer of number being assigned 0. If number is greater than 0, it's the first condition, then system will output number is positive. Else, if the number is less than 0, the system will output number is negative. Else, system will output number is 0. And so you can see the little bit of different keyword there with if, else if, and then else. And you can actually have a number of these else if statements between the if and the else, but you can get a large series of conditions to evaluate. It might be best at that point to use a select case or a switch statement. We saw an example of this with grades A through F earlier that compared their score to a range of numbers to get their grade. And the pseudocode might look like something like this, and you can see how this could get a little long. If the grade is greater than or equal to 90, then place an A on the report card. If the grade is 80 to 89, then place a B on the report card. If the grade is 70 to 79, then place a C on the report card. If grade is 60 to 69, then place a D on the report card, else place an F on the report card. It's probably better to use a switch or a select statement with this case. Okay, in this code, let's see, in JavaScript, C++ and Swift, the select statement uses the keyword switch. In this code, the year variable holds the number that the user has entered. So here our example, it might be for the user, might be entering how many years they've finished in school, 1, 2, 3, 4, or more. Instead of saying if 1 then freshman, else if 2, sophomore, else if 3, junior, else if 4, senior. You could use a case select like this example in JavaScript. The value stored in the variable year is being compared to each value that follows the keyword case. So in this code, the year variable holds the number the users entered. That number is in parentheses following that keyword switch. This value that the variable holds year is what's going to be compared to, or the condition to be evaluated for each of the cases. So the first case's condition would be like, is the value in years equal to 1? If true, then the variable rank is assigned the text freshman. And the break then tells the code to stop looking for all the rest of the cases because one was found true, and it will jump out of the entire select or switch statement to the code below. In this case, writing to the document the value of rank, which is freshman, that is below the switch statement. If that happened to be freshman was 1 year. If year was not 1 and that case was false, it will go down to the next condition to evaluate, is the value in years equal to 2? And so on until it finds the right true condition. If the user didn't enter the numbers 1, 2, 3, or 4, then the default code will run, which in our case tells the user that they didn't enter a valid number and assigns the variable rank the value of unknown. After the switch statement is done, the value of rank is then displayed. Let's try out the logic on our own by using a flip the coin example. If it's heads, tell the user they got heads. If it's tails, tell the user they got tails. And see how your pseudocode goes.